Hello students. So today discussion is about the chapter language of chemistry. So what does it mean? In this chapter we are going to discuss about all the basic concepts, basic terms and definitions and the clarities which you need to understand the concepts of chemistry. We'll discuss in this video. So language of chemistry. To start the discussion, students, define chemistry. What is chemistry? Like if the question is what is chemistry, what is your answer? Chemistry is a branch of science which deals about matter and its composition. This is the definition you can see in all the books. Yes or no? What is chemistry? It's a branch of science which deals about matter and its composition. That means matter means anything which has mass and occupies space is called as matter. Yes or no, students? Everything is matter. What that matter is made up of, what is the formula, how it is combined, what are the elements present in that, what is the chemical composition, how does it behave, what are the properties, physical properties, chemical properties, everything we'll discuss in this subject called as chemistry, matter and its composition. So we have different branches of chemistry for the easy of understanding the concepts. So first of all, inorganic, organic, physical, analytical as well as industrial, nuclear, biochemistry and nanochemistry. These are the branches we have, but mainly students, main branches are organic, inorganic, physical and general. So these are the main branches. So first of all, what are these organic chemistry and inorganic chemistry? I think in all these branches you might be familiar with organic chemistry. Yes or no? So simple. Like first of all, to start the discussion, students, we have 118 elements are there. Yes or no, students? And what is the element with atomic number 6? Carbon. So the study of carbon and its compounds is called as organic chemistry. So organic chemistry is all about carbon compounds only. So there are 118 elements. By why only carbon is so special, that we'll discuss in the chapter. So carbon organic chemistry means carbon chemistry, study of carbon and its compounds. The main reason is that we're all the life made up of carbon. We're carbon based life. So many compounds are possible with carbon. So carbon has a separate branch of chemistry called as organic chemistry, and remaining elements, the discussion of S block elements, P block elements, D block and F block, all the elements we'll study in this branch called as inorganic chemistry, excluding carbon compounds. Why? Because carbon compounds we already have organic chemistry, right? Clear? Got the clarity? Next, physical chemistry. In this chapter, in this branch of chemistry, we are going to deal about the physical principles, measurement, how to measure like a temperature, a pressure or a volume of an atom or a molecule, the shape. So like in study point of view, like atomic structure as well as be a solid state, liquid state, gaseous state. So all the numerical part, measurable properties we'll study in this physical chemistry, students. Next, analytical chemistry. Mostly you'll get in graduation or post graduation about analytical chemistry. It is a branch of chemistry that deals with the study of methods of detection of the elements and compounds, like how to detect. For example, like many satellites are roaming around the planet Mars. Yes or no? Like how can they detect a particular element using that comes under this branch of chemistry called as analytical chemistry. You have given a given sample of solution, how to you need to identify a compound present in that. So using the titrations, using molarities, concentration expressions, everything we'll study in this branch called as analytical chemistry. The satellites, there is a spectroscopy, that's how they can detect. So next, industrial chemistry. This is also very important in engineering point of view, students. Industrial chemistry is all about instrumentation. For example, we are surrounded by many compounds. As students, all the compounds, where these compounds are coming from? Let us take plastic chair, or let's say your laptop, or let's say your book. So where all these things are coming from? Directly from the nature? No, they're getting synthesized, they're getting produced. Some chemical reaction is happening behind that preparation. For example, plastic, or for example plastic covers, or in Edrika, take any example. We are all surrounded by many compounds, cement, fabrics, dye, coloring. So there are like different chemicals are there which everything is made up of, and how to synthesize that chemical and what is the reaction. Fertilizers are there, ammonia, synthesis of ammonia, how to synthesize nitrogen gas, hydrogen gas together in 1:3 ratio produces ammonia. So all the industrial oriented point of view, the study of these chemicals, in order to manufacture these chemicals, we'll study in this branch called as industrial chemistry. Very, very important student, this one also. So next, nuclear chemistry. Nuclear chemistry mostly focus on the energy. Nuclear means what? Nucleus. What's the meaning of nucleus, students? Nucleus means protons and neutrons present inside the atom. Yes, sir, an atom is made up of three main subatomic particles: protons, electrons and neutrons. Protons and neutrons are located at the center part of the atom called as nucleus, and electrons revolve around the nucleus. So if you can disturb this nucleus, it creates enormous amounts of energy, atomic bomb. So that's what we're disturbing the nucleus only, a nucleus of uranium, plutonium. So how to create that energy? By the nucleus, by disturbing the nucleus, or from the radioactive substances also, the substances which emits the radiation, which emits their own subatomic particles and convert into the more stable forms. That study is in nuclear chemistry. We study in nuclear, the branch of chemistry called as nuclear chemistry. Next, biochemistry. Biochemistry will get in graduation students. In general, in intermediate also there is a chapter called as biomolecules. So in this branch of science, branch of chemistry, we deal about we're all made up of also chemicals. Yes or no? Animals, plants, everything are made, everything is chemical to the nature. For example, let us take an example with a human being. So what are the what blood is made up of? What are the reactions happening in the blood? What are nucleic acids? What are lipids? What are proteins? What are vitamins? How to synthesize them? And what are the reactions happening? What are carbohydrates? How it is getting decomposed? What are polysaccharides, oligosaccharides, everything, the study about the reactions in terms of biology. We'll study in biochemistry. Last one is nanochemistry. Nano means very, very small. So students, nanochemistry is a new one. So more research is going on about this nanochemistry. It is a new discipline which deals with the unique properties associated with assemblies of atoms and molecules. That means assemblies of atoms and molecules means a single atom, a single molecule. We can even influence the at the molecular level also. For example, carbon nanotubes are recently being used in for the cancer treatment in the medicinal industry. Yes or no? Cancer cell is there to target the cancer cell. So there, many students have this doubt. Sir, in biology they study cell. In chemistry they used to study atoms. Sir, which is smaller? Cell is smaller or atom is smaller? So students, listen, the smallest unit is atom. Atoms combine to form molecules. Molecules and molecules group together with a force called as a cell, a mysterious force called as a cell. These cells and cells are single cell, double cell, all together form what do we get? A tissue. Next, organ system, organs, organism. So this is the order. Ultimately is atom only. Next, molecules. Okay, that is the way. And this nanochemistry deals about the molecular level, Buckminster Fullerene's buckyballs, like recent. These are all the recent analysis and research. So that is about nanochemistry, students. So chemistry is very interesting. Chemistry is a zoom-in subject. That means everything we can't show. You have to understand, you have to analyze, you have to imagine, and you have to visualize the concept. For example, a teacher is talking about an atom. Is it possible? Can we show an atom? No, you have to imagine. So that is what, students. So first of all, to start the discussion here after explanation of all the branches, symbol. So symbol means, students, you already might have learned about an element. Yes or no? What is an element? Define an element. An element means atoms of same type is called as an element. Like we are surrounded by, we are made up of on this planet Earth everywhere infinite number of atoms. Yes or no? So do all these atoms are the same or different? All these atoms are not same, they are different. What do they differ by? They differ by subatomic particles. So based on the protons, all these atoms are classified into 118 types. Each type is called as an element. Yes or no? Hydrogen element, all atoms with 1 proton each. Helium element, all atoms with 2 protons each. Neon element, all atoms with 10 protons each. Like that, 118 types are there. So each type is called as an element, and for the element they have a name. Yes or no? And those names are origins. Don't focus on their origins. Every element name has its own history, has its own origin. So that's why just look at the name, hydrogen. So every time, students, does this hydrogen exist in the nature as hydrogen only? No. It is reacting, yes or no? So every time if you want to mention that reaction, do we need to write the whole name? No, it's a time taking process. Definitely we need to give a shortcut, yes or no? Like who is the Chief Minister of Telangana? Like we can say as of now 2023 this year to KCR, yes or no? Are we saying the full name? No, a shortcut. We're following a shortcut or not? The same. A symbol is it is defined as a shorthand representation of an element, or a shortcut representation of an element is called a symbol. Instead of writing the full name, we can simply write H. Helium, simply He. And here for the symbol, students, there are some certain rules are there. Listen carefully. First, have you understood the reason for assigning the symbols, right? So each element has a unique symbol assigned. The symbol of an element is not used for any other element. For example, hydrogen is given as H. And one more thing, every time you should write the first letter capital only, capital H. Don't write small h. Helium also starts with H. Can we assign helium also H? No, right? Obviously. So big confusion. So definitely no two different elements have same symbols. Every element has its own symbol. Sir, how to write the symbol? Already symbols are given. You have to remember the symbols. On what basis they gave? Simple, the first letter in general, the first letter. But hydrogen, helium, first letter is H and H. Then the second letter, not every time the second letter. The most prominent letter, the most sounding letter. Students, remember this one. Hydrogen is H, capital H. Helium is H, E. And remember, if an element has two letters in the symbol, first letter always you have to write in uppercase, capital letter, and second letter always lowercase, small letter. Remember, this is also one of the rule. Chlorine, CHLORINE, chlorine. C, can we write C? C already given to carbon. So can we, is it CH? No, not the second element. Cl, most sounding, Cl, Cl. Chromium, Cr, like that. So already these are given. So you have to remember that not every time the second letter, most prominent letter, and it should be the small. The second letter is always small, the first letter always capital, remember. So we have seen that there are 118 known elements. Each of these elements have a symbol of its own. So by assigning all these symbols, what we can understand from the concept is, we have two things, students. One is qualitative meaning and quantitative meaning also. Qualitative meaning means in general, the particular symbol represents an element. So for example, O. What is the meaning of O? Instead of writing oxygen, simply O. O means the moment when you're seeing O, the moment when you're writing O, what does it mean? What you mean? Oxygen. N. What does it stands for? Nitrogen. Yes, sir, students. That is qualitative meaning. Quantity means amount. These symbols also indicates the mass of that particular element, students. Atomic mass also. So atomic masses are not mentioned in general, but every element has its own mass. Yes or no? An atom is made up of protons, electrons and neutrons. Protons and neutrons are providing mass for an element. So every element has its own number of protons, has its own number of neutrons. So definitely every element has its own mass. So these elements, carbon, see, what does it mean? Carbon's mass is 12 grams, students. Why 12 grams? That's not the study right now. Carbon's mass is 12 grams. By just looking, by writing that C, what you're representing, it is carbon and its mass is 12 grams also. Yes or no? That's the first thing you should get in your mind. So nitrogen mass is 14 grams. What does it mean? Nitrogen, you're writing N means it is a nitrogen element and its mass is 14 grams. Yes or no? So different elements have different masses. So these symbols represents qualitative meaning, what type of element it is, as well as quantitative meaning, how much mass it is. So next, atomicity of elements. Atomicity means, students, simple, number of atoms in a molecule. Number of atoms in a molecule. Students, these atoms, like what we discussed so far, these atoms, they combine to form a molecule. Yes or no? And how many atoms combine? How to know that? In the formula. Yes or no? For example, what is the formula of water? H2O. What is this 2? The number 2 which is represented at the subscript position. What is this number 2? This number 2 indicates there are 2 hydrogen atoms and 1 oxygen atom. There is no number in general for oxygen. Yes or no? What does it mean? In general 1. If there is no number in general, 1. So this number 2, the subscript numbers in a molecule, represents atomicity. Oxygen gas, what is the formula? O2. What is this number 2? 2 oxygen atoms present in 1 molecule. Got the clarity? That is atomicity. Number of atoms in a molecule. Sulfuric acid, H2SO4. 2 hydrogens are there. 1 sulfur is there. 4 oxygens. These are the atomicities. Got the clarity, students? The whole molecule for independent element also you can find. So atomicity, the number of atoms present in one molecule of an element is called as atomicity. Based on atomicity, the elements can be classified into different types. Like an element having only one atom, that is, a molecule with only one atom, that is monatomic. Molecule with 2 atoms called as diatomic. Molecule with 3 atoms is triatomic. More than 3 is polysimple. But here there is one point, students. What is, once read the monatomic element, the element with only one atom in the molecule is called as monatomic. What is the definition of molecule? Like when 2 or more atoms combined chemically, yes or no? When 2 or more atoms combined, but what is monatomic saying? Only one atom in the molecule. How can you justify that previous statement with this statement? Molecules, their definition is saying 2 or more atoms, definitely they are combining. But here monatomic saying, oh, there is only one atom in the molecule. What does it mean? The meaning is, students, in general, definitely 2 or more atoms only in a molecule. But there are some elements in the periodic table, in the nature also, they are completely unreactive. Those elements are also called as noble gases. For example, helium. Helium is present in the air. He, yes or no symbol. Is it reactive? No. Is it combining? No. So helium is considered as an atom as well as helium gas, which is also considered like a molecule. Helium gas, it's a gas, right? It is existing right in the air with other surrounding molecules. So that's why it is also considered as a molecule. So but only one atom is there, sir. No. So that's why for noble gases, helium, neon, argon, krypton, xenon, they're all one atom only. Why? Because they're not combining, uncombined. They're elements as well as molecules also. And look at other examples, copper, silver, of course, helium we discussed. Metals also, students. Metals, for example, iron, the most common metal we use in our everyday life, as iron. So iron, what it is made up of? Iron. But is it a single atom? No, there are many iron atoms are there in that iron bench or iron chair, whatever iron things. So but students, do these atoms combine with each other? No, there is a bonding. The bonding is called as metallic bonding, but that is not a complete chemical transformation, students. But still they exist, all these atoms exist in that form, yes or no? So that is also considered as a molecule. Single atoms are existing, right? So that's why, so even metals also like iron, copper, gold, all considered as monoatomic only. Why? Because they are existing. So next, diatomic elements. Diatomic means what? In the molecule, 2 atoms are there, yes or no? Oxygen gas. What is the formula? O2. What is the meaning? There are 2 oxygens present in one molecule. Nitrogen gas, 2 nitrogens in one molecule. And chlorine gas, Cl2, 2 chlorines in one molecule. Hydrogen gas, diatomic. Triatomic means 3 atoms in one molecule, O3, ozone. And polyatomic means more than 3. You can see the P4 molecule as well as S8 molecule, Si4 molecule. So polyatomic molecules in general more than 3. So that is atomicity. What is atomicity? Number of atoms present in a molecule. Next, this is also very, very important. Valency, students. Valency, Valency, valency. The combining capacity of an element is called as valency. The combining capacity means, like, what is the formula of water? H2O. Why only H2O? Why not HO2? Why not H3O? Why not H4O? Why only H2O? That is because of valency. Every element has its own capacity to combine. So what is the meaning of this capacity to combine, combining capacity? Students, chemical reactions mainly takes place by 3 ways. Chemical reactions takes place by 3 ways. One is by losing electrons, gaining electrons and sharing electrons. Elements, they lose electrons, they can gain electrons as well as they can share electrons. But how many? That is valency. An element is losing how many electrons? An element gaining how many electrons? An element sharing how many electrons? That number will be explained by valency, by electronic configurations. In the higher classes you will get about configuration. Here you used to learn about what is the valency like. So what is valency, students? Answer: combining capacity of an element is called as valency. What is the meaning of combining capacity? Number of electrons an atom loses or gains or shares during the chemical reactions. Understood, students? But in the olden ways, they used to find the valency by taking a reference element called as hydrogen. For example, look at here. In general, hydrogen is the first element, students. So it is valence is taken as 1. It has only 1 electron. Chemical reactions takes place only by electron. So Here 2 hydrogens are combined with oxygen in water. So what is the valency of oxygen? Answer. Hydrogen valency is 1, right? 2 hydrogens combining with 1 oxygen. Now what is the valency of this oxygen? Students, answer. The valency of this oxygen is obviously 2. Why? Because each hydrogen 1, right? 2 are there. Total valency 2. They are satisfying 1 oxygen. That means what is the valency of oxygen? 2 obviously. That is what? Ammonia, NH3. 3 hydrogens are combined with 1 nitrogen. Now what is the valency of nitrogen? 3. That's it. And methane, CH4. 4 hydrogens are combining with 1 carbon. That means what is the valence of carbon? 4. They are true, they are correct. That is the olden way of assigning the valencies. What is the new way? By electronic configurations in the higher classes. So next, valency in terms of oxygen, right? We can define valency not only in terms of hydrogen, in terms of oxygen and chlorine also. What is the valency of oxygen? 2, right, students? Valence of oxygen is 2. There is one element combining with 1 oxygen. Then what is the valency of this element? Valency of oxygen is 2. One element is combining with oxygen. Then what is the valency of this element? 2. Yes or no? One element is 2. Oxygen is giving 2 valency. So other element also 1 element only combining. Its valency is 2. If 2 elements, 2 atoms are combining with 1 oxygen, then what is the valence of each atom? 1. Yes or no? Each 1 and 1 together make 2 and it is combining with oxygen. Got the clarity? That is also we can define. Calcium oxide, CaO. 1 calcium combining with 1 oxygen. Oxygen valency is 2 and calcium valency also 2. So every time opposite valency and this valency should be equal. That's why I am saying 2 and 2 are 1 and 1. So in terms of chlorine, chlorine also same like hydrogen. Chlorine valency also 1. Hydrogen chloride. 1 hydrogen combines with chlorine. So what is the valence of hydrogen? 1. In terms of hydrogen, what is the valence of chlorine? 1. Yes or no, students? Ultimately, so sodium chloride, NaCl. 1 sodium combined with chlorine. What is the valence of sodium? 1. MgCl2. What is the valence of magnesium? 2 chlorines are there. Each chlorine is 1. 2 chlorines means 2. 2 chlorines combining with only 1 element. What is this element valency? 2. That's how we can find the valency in terms of chlorine also. So assumption in finding the valency, listen. The valency of hydrogen and all the metals is considered to be positive. Always metal, students, remember one thing, metals always show tendency to lose electrons. Metals always show tendency to lose electrons. So if they lose electrons, they will get positive valencies. Even hydrogen also. Hydrogen is a non-metal, but it also gives a positive valency. The valency of all the non-metals except hydrogen considered to be negative. So non-metals in general, they gain electrons and they'll get negative valencies. Like if an element gains 1 electron, gets -1. If an element gains 2 electrons, gets -2. If an element gains 3 electrons, gets -3. Even here it is given as except hydrogen, but hydrogen also can gain electrons to become hydride ion H-. Remember. So as a molecule of compound is electrically neutral, it is assumed that total positive valency in its molecule is equal to the total negative valency. What is the meaning of this point, students? A molecule, you know why they are combining? In order to get stable as well as in order to get neutralized. For example, let us take with HCl molecule. Okay, hydrogen is a non-metal, but chlorine is a highly reactive non-metal. Chlorine has a negative valency. Chlorine gains an electron. And what is the charge chlorine gets? -1. Hydrogen gets +1. -1 + 1 equal to 0. Let us take H2O molecule. Oxygen valency is 2, and I said -2. Each hydrogen is +1 + 1. So +1 + 1 how much? +2. +2 - 2 equal to 0. Understood? The positive valencies in a molecule are equal to the negative molecules. The molecules are always neutral. Remember, this is the main point. So variable valencies. Variable valencies means sometimes the metals can exhibit more than one valency is called as variable valency, mostly exhibited by the D block elements. D block elements means in the periodic table you will get from 3D series elements start from scandium. So these elements will exhibit more than iron also D block element, silver also D block element, gold also silver D block elements. So all these elements in general, not only D block elements, in general they exhibit all these variable valency. Even the higher members of P block elements like tin, lead also exhibit variable valency. If an element exhibits 2 different valencies, here also if an element exhibiting 2 valencies, then how to name it? For example, sodium, there is only 1 valence. You are saying sodium ion, it's fixed. Magnesium always loses 2 electrons. Magnesium ion, simple. Iron has 2 valencies. Like iron can lose 2 electrons, sometimes it can lose 3 electrons also. That means it can exhibit valency 2 sometimes, it exhibit valency 3 sometimes. Then how to name that? You know, students, how to name? Remember, if in the same element with two different valencies, one is lower, one is higher, sir, obviously the lower valency should end with OUS, the name. What is that name? I will show you. Higher valency should end with IC. That's it. You have to remember. Lower valency of the variable valency element should end with OUS. Higher valency should end with IC. An element with more than one. Look at here, iron. Like I said, Fe plus 2, Fe plus 3. What is the Latin name of iron? Ferrum. So, lower valence is called as ferrous. OUS, yes or no? Or in terms of Roman numerals also we can assign Fe2. 2 indicates the valency is it lost 2 electrons, yes or no? And look at here, higher valency. Fe plus 3 means it lost how many? 3. So, what is the valency? 3. So, what is the name? Ferric. You should end with ic. And look at the Roman numerals Fe3. Fe2, Fe3 or ferrous, ferric. Simply you cannot say iron ion, yes or no? If you are writing iron ion, which iron ion are you talking about? Is it iron 2 or iron 3? Can this confusion are there or not? So, to avoid that confusion, each and every valency of the same element given this nomenclature. Simple. Lower is OUS, higher is ic. Copper, its Latin name is cuprum. You answer copper has two valencies. One is Cu plus 2. Which is lower? Cu plus is lower, yes or no? So, what is its name? Cuprous or Cu plus ion or Cu1 according to the Roman numeral. Or higher valency Cu plus 2. What is the name? Cupric, Cu plus 2 or Cu2 plus or Cu2 ion. Silver, argentum, argentus, argentic. Mercury, mercurous, mercuric. Yes or no? Hg plus and Hg plus 2. So, this is the variable valency, students. So, lower valency should end with OUS, higher valency ic. Sir, we wrote the valency 2, we wrote OUS. So, wherever there is 2, can we write OUS? No, not like that. In the same element, 2 valencies are there. In those 2 valencies, you have to check which is lower, which is higher. Lower is OUS, higher is ic. Got the clarity? As well as we can also name in terms of Roman numerals with the element symbol or with the element name also. So, this is about higher valency. This is about the introduction about this language of chemistry. Separate branches are there, symbol, atomicity, as well as valency. So, many main concepts, students. I hope you got the clarity, and the remaining concepts we will discuss in the coming videos. Thank you, students.